So lesson 5 on alkenes, we're looking at preparation of alkenes. So preparation of alkenes. So under preparation of alkenes, alkenes can be prepared by using two methods. So two methods can be used. The first method is what you call catalytic cracking. Of an alkane. So catalytic, you have two types of cracking, catalytic and thermal cracking. So once you are saying catalytic, you're using a catalyst now, where we are going to break, which will help us to break an alkane to form an alkene. So in this situation, let's say, for example, if we have the big molecule, like let's say, let's get C10H22. So to break this one now, we know that we need some conditions that can help us to break this one. So put a catalyst here, then temperature as well. So these are the conditions that are needed to do this. So whenever we are changing alkene to form an alkane to alkenes, we'll produce a simple alkene, which is ethane. So write 4, write 2 there, write 2 here, then H4 plus. So the understanding here is this. Look at what we have here and what we are producing here. Remember that you need to balance whatever you're going to produce from this large compound. So we have C10, H22, meaning we have removed 2 carbons here, so we are remaining with 8. So I'm going to put 8 here. Then this 22 minus 4, we are going to get 22 minus 4, we are going to get 18. So this is a product of alkene. So we have produced an alkene and alkane. How can you know that this one is an alkane? This is simple. If you say 2 into 4, the answer will give you the whole number, which is 2. But 8 into 18, it will leave a remainder. So once there is a remainder, just know that compound is an alkane. Alkanes always leave a remainder. So we have 8 atoms of carbons there. So we can prove our answer to say Cn H2n plus 2. If you put 8 here to have C8, then 8 times 2, we're going to have 16. 16 plus 2, we're going to have 18. So this is an alkane here. So if you get the number of carbons into hydrogen, they leave a remainder. That is how we identify that this one is an alkane. But if the number of carbons can go into the number of hydrogen twice without any remainder, that one is an alkene. Then the other way we can prepare, so of course catalyst, we use aluminium oxide. So aluminium oxide, catalyst. Then temperature supposed to be 500 degrees Celsius to 600 degrees Celsius. So this is the range. That's the range. So the other method which we can prepare alkenes is what you call dehydration. dehydration of alcohol. In the previous video, we looked at hydration, where we added water to an alkene to form alcohol. Now we are dehydrating. So if we have C2H5 hydroxyl, this is ethanol. So ethanol can be dehydrated to form an alkene. So we just need to remove water. So to remove water, we'll say C2H4 plus. So get one atom here of hydrogen and put it here to have two. So we'll say now H2O. So we have produced our alkene by dehydration of alcohol. So these are two ways in which we can produce alkenes, by dehydration and cracking. So let's look at the last part, tests of alkenes. So testing of alkenes, we're looking at how can you identify if this one is saturated or unsaturated. So the first method which we use is we use alkenes can be tested by shaking an alkene into bromine solution. Okay. If alkenes are present, the orange color of bromine turns colorless. So the color of bromine is orange. So once you shake an alkene into this solution of bromine, if the color disappears or changes from orange to colorless, just know that hydrocarbon which you added was an alkene. So what we're saying is this: if we have bromine here plus hydrocarbon, which we don't know, then after shaking, so color orange. So this is before shaking. Then after shaking, you find that color becomes colorless. Then hydrocarbon is an alkene. So after you shake, then the color becomes colorless. Just know that. So after shaking, just know that the hydrocarbon which was added into bromine is now alkene. That is how we check. So by doing that, we can conclude to say if I have C2H4 which is ethane plus bromine. Then if it is an alkene, it will give me something like this. So bromine, bromine, then hydrogen, hydrogen, hydrogen. So ethene, bromine, then the product will be now 1 2. The reason why we are saying 1 2, it's because one bromine is on carbon number 1, the other bromine is on carbon number 2, so 1 2. Then we have 2 bromines, so 1 2 di. This di means we have 2 bromines, so dibromo. We don't say dibromine, dibromo. Then since we're looking at the alkene part, so it will become now dibromoethane. So that is the name, and that is how the reaction takes place. If they have not given you bromine solution, they can also use what we call potassium permanganate 7. Potassium permanganate 7. So potassium permanganate. So potassium permanganate solution, if it is being used, potassium permanganate solution can also be used. The color of this potassium permanganate, we know that the color for potassium permanganate is purple. So its color is purple. Its color is purple. So after shaking it into alkenes, then the purple color can change to colorless after shaking the solution with an unsaturated hydrocarbon. Remember, unsaturated hydrocarbons, these are alkenes. Example, alkenes. So that is how we can test if the solution, if the hydrocarbon is an alkene or an alkane. If you use alkanes, they have no effect. If the solution remains same, without any change, know that hydrocarbon which you use was an alkane, not an alkene. So that is how we test for alkane and an alkene, and that is how we can prepare alkenes from alkanes by using one, cracking, and dehydration. Thank you for watching.